Today our topic is dimensional formula. In the previous class we have seen dimension formula of few physical quantities like velocity, acceleration, then distance, displacement, etc. Today we will see the continuation of the remaining dimension formula of the remaining physical quantities. Okay. Now for our convenience, for our reference for the remaining dimension formula, we can list the dimension formula of velocity. What is dimension formula of velocity? We have seen it is L t raised to minus 1. M raised to 0 is there. Now I am not writing it. When you write the dimension formula velocity alone, you have to add M raised to 0. Okay. Then for acceleration, we have a dimension formula L t raised to minus 2. It's a dimension formula acceleration. Okay. Using this dimension formula, we can start deriving the others. Okay. So now we'll start with the first one dimension formula. We can write area. Area means when you find the area of any either the area of a square or rectangle, we are multiplying two length. So what is the dimension of the area? Dimension of area will be L square. You have to multiply two length. Each length has dimension of L. So what is the dimension formula? M raised to 0, L raised to 2, T raised to 0. It is a dimension formula of area. Now similarly we can get that of a volume. Volume means when you get a volume of any three-dimensional shape, you have to multiply three lengths there. So the volume will have a dimension formula L raised to 3. Then there will be M raised to 0 and T raised to 0. So M raised to 0, L cube, T raised to 0 is the dimension formula of a volume. So area and volume. Next we can see the dimension formula of density. So density, we know the equation of density. What is density? It is mass by volume. We know the equation. It is mass by volume. Mass has a dimension formula capital M. Volume we know it is L cube. So M by L cube. Or when we rearrange the terms, what will we get? We will get M L raised to minus 3. L cube comes to numerator. Then T, we don't have dimension. We don't have the symbol, so we will write T raised to 0. Okay, area, volume, and density. Now work already I think we have seen in the previous class. So anyway, I'll write the dimension of work once again. Dimension of work is equal to, we have the equation for work. Work is force into displacement, F into S. Now F, how will you write? F is equal to mass into acceleration, M into A into S. Mass, we have dimension formula M. Then for acceleration we can use L t raised to minus 2. So L t raised to minus 2. Then displacement we can write L. So when you multiply, what will you get? M into L, L square. So M L square, T raised to minus 2 is the dimension formula of what? That of work. So work has dimension formula M L square, T raised to minus 2. Okay. Now next we will say that of kinetic energy. Kinetic energy, we have the equation half mv square. Half mv square. Half we can avoid, no need of a dimension formula. M and v square we need. For M we will write capital M. For v square, for v we have dimension formula L t raised to minus 1. We can substitute here L t raised to minus 1, but you have to square this. So when you square this, M square of L is L square. So you will get M L square t raised to minus 1 the whole raised to 2 is equal to t raised to minus 2. You will get M L square t raised to minus 2. That is the dimension formula of kinetic energy. Next we need that of potential energy. Potential energy, we have the equation, we have learned the equation mgh. Mass into acceleration due to gravity into h. Mass has dimension formula capital M. Acceleration has dimension formula L t raised to minus 2. So M L t raised to minus 2. H is a distance, h is a length or height. Dimension formula will be L. So when you multiply, what will you get? M L square T raised to minus 2. It's the dimension formula of potential energy. So it is interesting to see that these three quantities, work, kinetic energy and potential energy, all these three have same dimension formula M L square T raised to minus 2. We will see one more physical quantity having same dimension formula, that is called torque. About torque we will see in rotational motion in +1. Now torque has an equation. Torque is equal to R into F. Actually it is called cross product. We will simply write R into F. Distance into force. Distance has dimension formula L. And force has dimension formula what? Mass into acceleration. For mass we have m, for acceleration L t raised to minus 2. So when you multiply, what will you get? M L into L square t raised to minus 2. So we have seen 4 physical quantities having same dimension formula, that is work, kinetic energy, potential energy and torque. Okay, so we have seen 7 dimension formula. We have seen first one, that of area, then volume, density, work, kinetic energy, potential energy, torque. Now we can see the next one. We can see momentum. What is momentum? Product of mass into velocity. So momentum has an equation. P is a symbol of momentum. Mass into velocity. Momentum. Mass into velocity. M is for mass. For velocity, what we can use? L t raised to minus 1. So ml t raised to minus 1. It's a dimension formula of momentum. There is another term similar to momentum. It is called a moment. Moment means the product of force into distance. F into x is called a moment. Force into distance. Force as a dimension formula, we have used a force. Force the dimension formula ml t raised to minus 2. So we can use here ml t raised to minus 2 for force. Then distance, we have L. So when you multiply, what will you get? You will get m L square t raised to minus 2. This also has got same dimension formula as that of work, energy, torque, like that. Okay, so there are many physical quantities having same dimension only. You have seen here work, kinetic energy, potential energy, torque. Then moment also has got a same dimensional formula. This is 9th one. Now 10th one we can use pressure. What is pressure? Pressure is equal to force by area. Force by area. For force we have dimension formula ml t raised to minus 2. We substitute here ml t raised to minus 2 divided by area. We have L square. We will divide by L square. So 1 L cancels. This L comes to numerator. M L raised to minus 1 t raised to minus 2 is the dimension formula of what? Pressure. Okay. Now 11th one we will see power. What is power? Power is equal to work divided by time. Work by time. Work has dimension formula ml square t raised to minus 2. So dimension formula ml square t raised to minus 2 for work. Then we have divided by time. What will you get? You will get m L square. This t also comes to numerator. It will be t raised to minus 3. This is a dimension formula of power. Okay. So today we have seen, in this session you have seen dimension formula 11 quantities. I'll write one more dimension formula. I'll make it 12th one. I'll write the 12th dimension formula to be, we can select that of frequency. I think you have seen in previous class. Now I'll write angular frequency. Angular frequency means, angular frequency has an equation. Omega is a symbol of angular frequency. It has a relation 2 pi nu. Nu is called a linear frequency. Omega is called angular frequency. How will you write? 2 pi does not have a dimension formula. This is frequency. So 2 pi, no need to give any dimension formula. Nu is frequency. What is the dimension formula of frequency? It is t raised to minus 1. So dimension formula will be t raised to minus 1. Now formula for m raised to 0 and L raised to 0. So this is dimension formula of angular frequency. Omega represent angular frequency. So angular frequency and frequency having same dimensional formula. Okay. So we have seen in the same page you have seen 12 dimension formula. Now we have continuation. Not only 12, we have large number of dimension formula to be written today. Okay. So I am rubbing this. We are rubbing the dimension formula of these quantities. Okay. We have seen up to angular frequency. Now we can continue. We have written 12 dimension formula. Now we can start with the 13th dimensional formula. 13th dimension formula we can start. Okay. We'll write 13th one. It's a new dimension formula. 13th one. We'll write potential difference. Okay. Potential difference V. We have seen the equation of potential difference V is equal to W by Q. Work divided by charge. What is dimension formula work that we have seen previously? Work has dimension formula m L square t raised to minus 2. Divided by charge has dimension formula. Charge means current into time. Current has formula A time has 8. A into t. So when you rearrange, what will you get? ml square. A will come up, a raised to minus 1. T also comes to numerator, it will be t raised to minus 3. It is a dimension formula of what? Potential difference. We indicate potential difference. If you know potential difference, we can get dimension formula of resistance. R is equal to V by I. So just divide V by I. V has dimension formula this. ml square a raised to minus 1 t raised to minus 3. So ml square a raised to minus 1 t raised to minus 3 divided by current as a symbol A. Dimension symbol A. So when you rearrange, what will you get? ml square. A also coming to numerator. So a raised to minus 2. Then we have a t raised to minus 3. This is a dimension formula about resistance. Okay. Now we can write that our resistivity also. You know resistivity rho is equal to R into A by L. This is the equation. R into A by L. R resistance. We have the dimension formula here. So ml square A raised to minus 2 t raised to minus 3 into area. What's the dimension of area? Just before you have seen, area has L square. Length has L. So one L cancels. So this L comes along with this L. So it will be L cube. So we will get ml cube. Then a raised to minus 2 t raised to minus 3. This is the dimension formula of what? Resistivity. Okay. So we have some dimension formula of resistivity. Now we can see a few constants. Dimension formula of few constants. We will start with the gravitational constant. So gravitational constant you have learned in 9th standard. Capital G is the gravitational constant. So we can write as 16 to 1 gravitational constant capital G. What is the equation? We have seen the equation F is equal to G m1 m2 by d square, the equation gravitational force, universal gravitational force. So what is G from this? G is equal to F into d square, force into distance square divided by m1 m2. So we need to get the dimension formula G. F, what is the dimension of force? Mass into acceleration. Acceleration has L t raised to minus 2. Then distance square. Distance has dimension formula L, so L square. There are two masses multiplied, dimension formula m square. What will you get when you simplify? 1m cancels. You will have only this m cancels here. This m comes up. It will be m raised to minus 1. L into L square, L cube, then t raised to minus 2. It is a dimension formula of what? Gravitational constant. Okay. Now we have another constant called the Planck's constant. Planck's constant. Planck's constant has a symbol small h. Equation we have energy is equal to h nu. H is Planck's constant, E is energy, nu is the frequency. So what is the equation for h from this? H is equal to E by nu is the equation. So equation for Planck's constant is E by nu. E is, what is E? E indicate energy and nu is the frequency. What's the dimension of energy? Previously we have seen energy. It has dimension formula ml square t raised to minus 2. Frequency has dimension formula t raised to minus 1. T raised to minus 1, 1 t raised to minus 1 cancel. Remaining will be, there will be t raised to minus 1. So what's the dimension formula? ml square t raised to minus 1. This is the dimension formula of Planck's constant. Okay. Now we can see a few other formula like 18. We can see impulse. What is impulse? Impulse is the product of force and time. I can write F into T. Force has dimension formula m, mass into acceleration, ml t raised to minus 2 into, there will be a time. So what will be the result? ml t raised to minus 2 into t raised to 1 is equal to t raised to minus 1. ml t raised to minus 1. Okay, this is the dimension formula impulse. ml t raised to minus 1. Then we can see dimension formula of, so we have seen a few common dimension formula, that of velocity, potential difference, resistance, resistivity, impulse, force. Now we have another quantity called the moment of inertia. The equation for moment of inertia is, moment of inertia, we can give the symbol mi. Moment of inertia is equal to, the general equation is m into r square, mass into distance square. So what will be dimension formula? M distance square, it will be L square. So we will write t raised to 0 also. This is a dimension formula of what? Moment of inertia. Moment of inertia. Okay, so we need to see one more dimension formula, that of coefficient of viscosity. Coefficient of viscosity, we'll see dimension formula. I'll write equation for coefficient of viscosity. We have viscous force, I can write like this, Fv. Viscous force equal to eta. This symbol is called eta. It is denoting coefficient of viscosity. Then area into V by X. This is equation for viscous force. So what is eta? Eta is called a coefficient of viscosity. What is the dimension formula then? Eta is equal to, when you multiply, Fv is a force, then X divided by area into velocity. So we will get dimension formula now. Force, we know m, mass into acceleration L, t raised to minus 2. X is a distance, we have to write L. Area, we have L square. This is velocity. For velocity, what we have? L t raised to minus 1 is velocity. Now we need to simplify this. Only one m here. L into L, L square. Here also L square. These two L square cancels. This L comes up, L raised to minus 1. T raised to minus 1 cancel with a T raised to minus 1 here. So remaining is T raised to minus 1. This is the dimension formula of what? This is called a coefficient of viscosity. Coefficient of viscosity. Okay. So totally we have seen almost 19 dimension formula today. So similarly, by using the equation, we can get the dimension formula of each physical quantity. Then I'll write one more dimension formula to make it 20. 20th one we can write angle. Angle. What is the dimension of angle? So actually angle does not have a dimension formula. So how will you express the dimension formula? M raised to 0, L raised to 0, T raised to 0. This is for angle. Okay. So today actually this is the second session. In first session already we have seen how can you express dimension formula of a few simple quantities. Now we have seen the remaining dimension formula. Okay, around a 20 dimension formula you have seen today. So my request is don't try to by heart the dimension formula. A few basic dimension formula you can by heart, like that of velocity, acceleration. Then other dimension formula we can derive if we know the equation. So this is a correct method of obtaining the dimensional formula. Okay, thank you.